Hi, I'm Dario, Senior Developer Evangelist at HTC, and welcome to the ViveCon 2021 Developer Session, Developing for Vive, What's New? This session will consist of 3 short presentations. I'll start off with the key featured topic, and then we'll have 2 developer partners share their insights and experiences. So stay tuned, as immediately following me will be Hermes from Agora, followed by Alex from Agile Lens. So what's new? Well, for this short presentation, I'll be focusing on just a few features of our new Wave 4.0 update. I'll be going through an overview of what we feel are key features regarding performance and optimization, which will be useful for both beginner and seasoned developers. VIVE Wave is an open platform and toolset that enables development for mobile VR devices while providing high-performance device optimization for third-party partners and developers. It's essentially everything you would need to run VR on an Android device, based on our extensive experience with Android and VR. Its initial design goal is similar to what we have with OpenVR on the PC, making it approachable for VR developers new to Android coming from the PC. It supports multiple HMD and device configurations, from 3DOF to 6DOF controllers, from all-in-one to all-in-two. Basically, it can run any mobile Android device tethered to an HMD or embedded in an HMD using single or dual panel displays. The Wave platform also includes a set of SDKs, which include an OEM SDK, and a device peripheral SDK. The new Wave 4.0 SDKs also support the very latest versions of Unreal and Unity game engines. And additionally, in Unity, you can wrap the Wave APIs with our cross-platform toolkit, the Vive Input Utility, also known as VIU, thus making it possible to maintain one codebase across platforms and devices. And yes, the Unity Wave XR plugin also supports the latest Unity XR Interaction Toolkit, thus making Vive Wave future-proof. The multi-layer feature is an overlay rendering solution for Unity Unreal. One of the issues with textured content rendered by game engine is using the iBuffers, where the quality is really low. As you can see, the comparison here is quite evident that on the left here, the textured content rendered in the iBuffer is just not as good quality as the multi-layer overlay used on the right. This feature is useful when displaying any textured content that is meant to be the main subject of a scene. For example, in addition to text, you can have videos or other media content for improved quality using the overlay. And the way this works is that the multi-layer directly samples the textured content and applies ATW to it, asynchronous time warp. Multi-layer includes a couple of extra features like cylinder overlay, which uses multi-layer to display textures on a curved surface. The surface parameters can be customized. It's useful when you're displaying a texture with a wide aspect ratio for content placed at the user's line of sight. Another feature is the new editor tools. You can actually preview these layers inside the Unity editor to get a better understanding of how the layer will look. There's also the feature to create underlay mesh generation. This is required for displaying quad and cylinder underlays according to the layer parameters. And just for now, this is on Unity because the iBuffer rendering is a little trickier to expose in the editor with the Unreal Engine, but we hope to address that in the future. Here's a graph showing what it's like without the multi-layer and with the multi-layer. Just looking at the bottom here, you can see that the texture sampling, it's only occurring once. It's not done in the content image. It's done directly on the warped image from ATW. Now, one of the artifacts from using asynchronous time warp that you may have noticed is jitter when you look at the controllers, even when you're at max frame rate for the device. So we added this new mode called the time warp stabilized mode, which improves the smoothness of this case by not discarding the late frames. The penalty is just a single frame of latency, and the mode by default is set to auto, meaning that it's only turned on when you're at the max frame rate on the Focus 3. Adaptive Quality 3.0. We've introduced some new modes, making it easier to enable AQ quality mode and AQ performance mode. Before we had all these parameters and levers, so to speak, that you had to really carefully balance. So we've made it easier just by selecting quality or performance mode. You'll get those set. Now you can also override that and still be able to tweak each one of these parameters. If you look on the left, when you select AQ quality mode, of course, you're going to increase the quality, which is very visible here in these images. But of course, that means a bit of a frame drop. On the performance side, which is actually the default, you can still maintain quality when you have foveated rendering enabled, which is automatic. So you can see that on the right side, bottom left part of the right side, you can see some of the differences there. Controller tips optimization. So we've optimized controller tips dramatically. As you can see here, there's a significant drop in draw calls than what we had previously. There's also more display options. You can choose polyline as well as a fading effect. We've also introduced the controller orientation feature. A known pain point that I've experienced as well is that different controllers have different shapes and different identities. So instead of manually adjusting the pose for different controllers for these different identities, you can now request the pose for these 3 common identities. So starting from the bottom left here, we have the trigger oriented identity. In the center, we have the panel oriented, which is actually the default for our interaction mode. And on the right, the handle oriented identity. And basically what this means is you don't have to worry about adjusting the rotation and the position for lining up the origin part of the controller. For Unreal developers, there's a new architecture for wave models and controllers. Basically, we've listened to developers. Previously, the WaveVR SDK provided a WaveVR_pawn plus controller loader. This isn't common usage and a bit inconvenient for Unreal developers. It requires some effort to maintain native code and blueprints and to sync between actors. So we've addressed this by making it more intuitive to visualize the HMD in controllers, and it now integrates better with Unreal Pawn and Motion Controller, making it much easier to port and to extend. High quality system menu. So basically we're practicing what we preach. We've gone through the system, specifically the system menu, and we've improved the text quality dramatically. We've also mitigated aliasing. Heads-up display tool 2.0. So previously we've had a HUD tool, which was good, but this time we've added some more features. New profiling items such as foveated level, AQ level, pose prediction time. So when you launch this, now you get a nice UI-based settings display window, which you can see here under the screenshot. It's in this settings window that you actually enable it, so it runs in the background. You select if you want logging to an output file and so forth. On the left here, you can actually see the overlay in this Sea of Cubes app. It's kind of difficult to see it in this app, but basically you're getting a real-time graph. And again, this will run behind the scenes and collect this data. You can also turn that off by launching it again and going through the settings. Render doc support. Well, this is something that's very widely used by developers. If you're a developer and don't know what render doc is, shame on you. No, but seriously, this is something for graphic debugging. It allows you to capture all the graphic instructions to later play them back. So this is highly rich information for graphic debugging. You can actually trigger the capture from the PC, or you can trigger it from inside your VR content. And currently we are supporting version 1.9. I know the very current version of render doc is at 1.13 at the time of this, but we will always be improving and supporting the latest as much as we can. Again, it's a very valuable tool, and please feel free to use it if you haven't used it. Direct preview for Unity. That's another one that we've had before. It's just, we felt that it's important to continue mentioning that this is a very simple way of painlessly developing without actually going through the whole compile and install cycle, constantly installing APKs. So basically right from within Unity Editor, you can hit on the play button and you can actually do a direct preview of it inside your headset over Wi-Fi. Now, it's not quite the same as actually running it in the headset, but it definitely saves some cycles if all you're doing is debugging interactions. There are other additional tools as well. There's ways of using asset bundles. In our VIU toolkit, we can also use a simulator, which doesn't require a device, but all these tools are very valuable in saving you time. Our R&D team have continued researching performance tuning. Some of these are the results, which show the impact of triangle count, draw calls, texture size on application performance. The aim here is to help developers fine-tune the application performance for a different target platform or device. Now, let me zoom in a little bit on these graphs here. We can see in this chart that green is at frame rate, 90 frames. In the yellow area, we're from 75 to 90. In the brown, it's like 63 to 75. But basically, you get an idea when you play with all these levers, so to speak, what effects you have. So on the y-axis here, we have the try counts. On the x, we have the draw calls. And what these charts are showing is the different effects of using different amounts of memory for your textures. Obviously, at over 150 megabytes, then you really start losing some frame count there. So this is basically working towards creating more information for the developer for specific devices, some possible tools and so forth. It's just ongoing research that we're doing to help optimization. But what if your app can't feasibly optimize performance further, or it's basically bound to your PC because of GPU and CPU requirements, or you simply would prefer to stream to the Focus 3? Well, we've got that covered. Thanks to our partner NVIDIA, we have the cloud streaming client working on Focus 3. As you know, the Cloud XR server integrates with OpenVR on the Windows platform. And currently, if you've tried out the Cloud XR Client SDK, you can see that it already supports Wave. It's running on Focus Plus. And we have Wave 4.0 support coming soon. Additionally, we are also announcing the VIVE business streaming solution, which provides the ability to stream PC-based OpenVR content to the VIVE Focus 3. It's fully optimized for the VIVE Focus 3. And of course supports high resolutions. So what else is new? Well, if you come to our portal, developer.vive.com, you can find out things like what's with our support for OpenXR, or tips and samples of how to support accessibility, or basically the place to go to download all of our SDKs from eye tracking, facial tracking, hand tracking, and so on. It's the easy to remember URL, developer.vive.com. You can get all the information there, downloads. And if you have any questions, technical or developer questions, we have another easy to remember URL, forum.vive.com. And unless you can catch us today at our virtual booth, this is the location to actually meet up with engineers that also come to the forums to answer questions. If you visit forum.vive.com, you'll see that there's a whole section of developer forums, basically a forum for SDK and device. So if you have any question, this is the place where you can actually reach out to us. And with that, thanks for your time. I'd like to pass it over to Hermes from Agora now.
Thank you, Dario. Hi, I'm Hermes Francoudis, Senior Developer Evangelist with Agora. I lead a team focused on building guides and tutorials showing developers how to add real-time engagement such as voice, video, and real-time messaging to their applications using Agora.io. And I'm here today to talk about developing with VIVE and adding real-time engagement to your virtual reality apps. As the VR and XR market grows, it will demand innovation across both consumer and enterprise verticals. The Agora HTC partnership comes at a pivotal moment to enhance the cutting-edge metaverse use cases with the collaborative power of real-time engagement. Let's unpack that statement. In the early days of VR, it was very much a single-person experience. So if you weren't wearing the VR headset, the only way you could participate is to passively watch, generally by being in the same room, looking at a TV that shows the virtual world directly from the HMD's perspective, pulling the audio and video streams directly from the computer powering device. As VR evolved, it became more collaborative, allowing people to put on their headsets, get transported into a virtual world where they could see and interact with other VR users. This type of real-time engagement was groundbreaking in the virtual collaborative space. There's only one problem with this momentous shift. It still created a very high barrier to entry for those that didn't own a headset. It created a group of haves and have-nots, separating users. The people with the headsets were able to put them on, enjoy, interact with other users, where the people without the HMDs were once again regulated to the sidelines, sitting in the same room, or possibly however far the HDMI cable takes you. So why does this lack of accessibility matter? As the business world went remote, communication, collaboration, training all went virtual in one way or another. In both physical and virtual worlds, communication, collaboration, and training tools need to be flexible. So overnight, telepresence became a requirement. So how does this look in VR? In the physical world, we saw the shift from working, meeting, engaging locally to joining meetings remotely, where everyone is now remote. But in the virtual space, there's no real concept of remote and local users. Everyone is in VR, engaging locally. Once you put on your HMD, you're instantly transported to the virtual world where physical distances don't matter. If physical distance no longer defines remote versus local, what does? In VR, the differentiator between remote and local is actually physical versus virtual. And just like with the early days of remote work in the physical world, remotely joining VR still has a lot of barriers. Such things as, how do you allow non-VR users to participate and actively engage in VR? How do you make the VR experience more immersive? Next level immersion is engagement without barriers. What's that look like? It looks like this. In the virtual world, someone could hold a meeting with people from outside the virtual world, where people remotely join, streaming their voice, video, and even their screen if necessary. And this is where Agora can help. Any device, any network quality, lowering the barrier for engagement. This is what true digital ubiquity looks like. So what is Agora? Agora is a real-time engagement platform as a service. As fancy as the name sounds, at its core, it's a real-time network and a set of SDKs and APIs that make implementing real-time voice, video, and messaging as simple as possible. Developers and tech teams can build with confidence without having to worry about the intricacies of backend networking and scaling infrastructure as your product grows. Agora's network is built upon two core principles: scalability and low latency. These also happen to be two of the many advantages of Agora's network versus the public internet. To appreciate what that means, we have to keep in mind that the public internet is a patchwork of networks that follow a way of communicating. So it was designed to scale, but without any regard to the efficiency in the number of hops, handshakes, or the network congestion between the devices. Ultimately, this leads to increases in latency. In VR, it's important to have the lowest latency possible because it's paramount to making interactions feel fluid and realistic. And Agora can provide that low latency because of its globally dispersed 200 plus data centers that use industry-leading smart routing to ensure the most efficient path between devices and ensure the lowest latency. Agora's network also features industry-leading anti-packet loss technology that allows for voice and video to stream fluid regardless of network conditions. Aside from low latency, the other thing that matters in VR is scalability. Agora's network supports over 40 billion minutes of usage per month, and Agora's SDKs provide a variety of different use cases for people to connect, whether it be one-to-one or small group chat, or even live streams with over 1 million people. Agora is there to scale with you and your product. Agora's products enable a wide variety of use cases, ranging from education to social to remote collaboration and virtual training, just to name a few. But what really sets Agora apart from traditional streaming technology is that it's real time. In traditional streaming technology, real time meant generally about 3 to 7 seconds worth of delay. Not bad for passive consumption, but that's truly unacceptable for a conversation or asking questions or providing feedback in real time. Traditional video streaming flows in a single direction, from creator to a consumer. Agora allows for two-way communication, where everyone can see and hear each other and communicate in real time. Agora empowers developers building with the VIVE 4.0 SDK to remove the barriers for real-time engagement within their applications. Using Agora's products alongside the HTC VIVE 4.0 SDK allows developers to really remove the barriers within the enterprise. By integrating into existing enterprise applications, you can easily bring VR into the conversation, into your existing tools. No longer do you have to have separate tools for VR and non-VR. Now you can blur the line and really help grow and scale the influence that VR has within the enterprise. Agora offers both an Unreal and Unity SDK to make building real-time engagement into the virtual environment as simple as possible. But we also allow developers to build for Android, iOS, macOS, Windows, and web. We even offer other cross-platform SDKs such as React Native and Flutter. With all these SDKs, Agora makes it really easy for developers to add real-time engagement both to their VR apps and non-VR apps, and really scale VR within the enterprise by connecting users across existing tools and into new tools. So how can you add real-time engagement to your VR app? As I mentioned earlier, I focus on building guides and tutorials for next-gen platforms such as VR for developers to help them integrate real-time engagement into their apps. To celebrate the VIVE 4.0 release and the release of the new HTC VIVE headsets, I've created a guide that shows you how to easily integrate the new VIVE 4.0 SDK along with the Agora Video for Unity SDK that's available through the Unity Asset Store. In the guide, I'll walk you through how to set up the project using both VIVE and Agora, how to create a 3D environment, along with how to implement Agora using our virtual camera prefab. The prefab makes it easy for you to quickly drag and drop it into your scene and get going with Agora without having to write any code. Simply add the prefab to your scene, add your Agora app ID, the channel name, and then drag over your virtual camera, your render texture, and the root nodes of where you'd like your remote videos to show up. And that'll quickly get you started with rendering your virtual camera into the channel. I'll also show you how to connect non-VR users through a web-based interface to make it really easy to connect users from the VR and non-VR space and make a really, truly ubiquitous digital experience. If you'd like to try it out, scan the QR code on the screen and give it a go. Thanks for your time today. I'd also like to thank Dario and the HTC team for the opportunity to be part of ViveCon 2021. If you'd like to learn more about Agora, please visit agora.io. If you'd like to connect, feel free to reach out via Twitter or LinkedIn, and I look forward to seeing all the virtual real-time engagement apps that everyone builds using HTC Vive and the VIVE 4.0 SDK.
Hi there, I am Alex Coulombe of Agile Lens Immersive Design, and it is a pleasure to be here at ViveCon 2021. Apologies in advance if you hear goats, chickens, children, rain, anything like that during my talk. Isn't it a joy to record from home? Absolutely. Today, I'm excited to talk about what we've been experiencing with the VIVE SDK 4.0 platform so far in our short but meaningful time with it, and especially with the Vive Focus 3. First of all, who am I? What am I? Of course, the answer to those questions is Alex Coulombe. I wear many hats. As a conference organizer, I have been involved in the Fifth Wall Forum, the Theater Communications Group Annual Conference, and the Real-Time Conference. As an educator, I've been an instructor of Unity 3D at my alma mater, the Syracuse University School of Architecture. I've also taught VR live performance at NYU Tisch as part of the Brendan Bradley Integrative Technology Lab, and now I'm something of an on-call Unreal Engine authorized instructor partner for Epic Games, specializing in the AEC and virtual production industries. I also co-founded Agile Lens. What is Agile Lens? Well, an excellent question. We are an XR creative studio based in New York City that began very squarely focused on virtual reality architectural visualizations of theaters designed by Fisher Dax Associates, world-famous theater consultants, but over the years, AgileLens has taken all sorts of baby steps out from there in both the architecture and theater directions. To help triangulate what I mean by that, it's easier to just mention a few recent projects, such as in October 2020, working with Unity 3D and Metastage on the world's first volumetric keynote. This was for the Unity for Humanity Summit, so we had to build a virtual set, and Metastage, of course, shot Jessica, and we shot her on location. I had a whole VIVE Pro virtual production setup. Very cool. Before the Intel i9 became publicly available, we also got early access to that to build a VR fan experience for Intel, getting thousands of animated audience members into a virtual stadium, and yes, of course, having lots of fireworks. We also worked on the Infinite Playa last August and September, which was an Unreal Engine pixel-streamed multi-user official metaverse multiverse of the Burning Man experience. And you could drive art cars and ride bicycles and watch live shows, all with other people who you could talk to. And we also worked on a VIP VR implementation of that, which was not pixel-streamed, but now that I know more about Cloud XR and VIVE business streaming, maybe we can get there. Also want to mention briefly the work we're doing with the Perlman Center, which I can't speak much about, but we are working on a very forward-thinking hybrid live remote actor audience setup, and something similar actually for Legoland New York. We have an event coming up where we actually will have remote virtual actors interacting with guests on site. And you might think that all this hybrid VR live performance stuff really only started to happen over the past year, but in point of fact, actually, this has been going on for a little while. In early 2018, Philip Rosedale, founder of Second Life and later High Fidelity, and I were both speaking at a conference in Boston, and we got mutually excited about the prospect of creating compelling live content in social VR. So they kindly sent us a bunch of equipment, like 36 Vive trackers, and hired us to study everything from avatar types to performance types, write up case studies on what worked and what didn't, figuring out what fidelity of tracking was needed, what happened with mask work, all sorts of things. We brought on a bunch of incredible collaborators, actors, virtual cinematographers, and we called that Supergroup Alive in Plastic Land. And together we tested all sorts of different performance methods and even had some live improv shows. The lessons from that led directly into Love Seat at the 2019 Venice Film Festival, where the actors had full body tracking with Vive Pucks and wireless Vive Pros, and the audiences could watch the show live in person in Venice or live from VR anywhere in the world. Unfortunately, I can't show you images of Love Seat, but if you Google Venice Film Festival Love Seat, you'll see some great shots of Vive Pros and Vive trackers working together. Thank you, HTC, for the generous support on that front. So as you've seen, I love architecture, I love live events inside architecture, and I love tinkering with how to take advantage of emerging technology to make spaces and experiences even more vibrant, especially when they're entirely virtual, like most of the things of the last year, right? Thankfully, we're getting better and better at that. Let me tell you about one project that will lead into the work with the Vive Focus 3. I remember how starting in 2013, when I first put on a VR headset in one of our theater designs and was able to think, oh, wow, hey, it's like we're here in row cube C13, that it would be amazing if instead of just using VR as a visualization tool, we could get the design team to commit to using VR as an active part of the design process, where we customize an ongoing VR project to that particular project's needs. So about 2 years and change later, in 2015, we started this project, the Brockman Hall for Opera, and we were able to get that commitment. And very early on, of course, we were just using SketchUp and keeping things simple and clean, just analyzing space, checking basic sight lines, putting things on stage, playing with all of that in Unity 3D. You know, do we want to go with this blue scheme or this green scheme? Yeah, the green scheme feels better in VR. Then we started using a Vive tracker once I took it off my ceiling fan. Anyone remember that? Yeah, that was fun. And we started to use that Vive tracker as a design tool to help us actually have a one-to-one relationship between a seat in the real world and the virtual world. And that helped us actually decide with a lot of precision where the seats in the hall could go. We also began to review egress paths with different aisle options, light locations up in the catwalk, chair rotations, all the while keeping a record of the different phases of design so we could always review where we'd come from and where we were going. Then eventually, the project started to get more photorealistic with its needs, lighting, colors, subtleties like that, materials. So we headed over to Unreal Engine and took our VIVE into the VR editor mode to make some adjustments there and test things out. And we could even crank out some 2D renders, which were super useful. And then we could even simulate performances that might go on stage. Could even be around some creepy zombie people if we wanted to be, just to animate, the whole room, or feel what it's like to have the house at different capacities, or what's it like in VR to get a standing ovation. Eventually, we had something that looked a heck of a lot like what the built project was eventually going to look like. If you want to know more about the process and how VR helped us design this theater from the inside out, then please do check out my talk from Next Build 2020 entitled How VR Helped Us Design a Theater from the Inside Out, available on YouTubes everywhere. Once we were done or near done with the project, we had someone say, hey, could we see this project in a standalone VR headset? I want to just be able to, have the project on hand to showcase. Someone says, hey, how's your project going? And just put it on their head and they have this beautiful VR 6-off experience of it. And I said, well, we could do a 360 version that looks really good because it'll just be renders, or we could do a 6-off version that uses some of the earlier versions of the design in a much simpler style. And I sent them some of the work that we had done in standalone VR at that time to give them some idea. And they said, no, the design is way past that level of abstraction. We want to show people what the project is actually going to look like once it's built now. And I say, well, I'm sorry, but a standalone headset just can't show what you're trying to show right now. You're going to need to be tethered to a powerful computer. And they said, well, that's too bad. And I said, yeah, I'm sorry, but here, do please enjoy this perfect digital replica of your gorgeous theater that does still look great on a Vive Pro with a good computer. But a couple years later, here we are. And oh, hey, look, a metahuman. Looking pretty good. And, I feel like they're talking right to me. Wow, look at that hair. But where are we right now? Oh, a theater. Ooh, so nostalgic. It feels so real. And the amount that I miss being in a theater feels so real too. Can we jump around to the different seats? Why, yes, we sure can. Can we test the sightlines going down a row of seats? Yes, it seems we can. What about starting from the back and going forward? Well, I guess we can do that too. Can we lean on the balcony and see how that affects our view? You betcha. Wow. Boy, it sure would be great to use a tool like this, to upsell yourself into buying some even better tickets for a live show. When we be allowed to be in theaters again, wouldn't it be great to just, bounce around to a bunch of different seats and say, actually, oh yeah, this seat is worth $20 more. I think that'd be pretty great once we're allowed to be in theaters again. Okay, some notes about what you just saw. We are in Unreal Engine 4.26.2. We are running totally standalone, all on device. This was all put together in really just a few moments of spare time over the last couple weeks when I first got access to the Vive Focus 3. The frame rate is better in headset. Of course, recording an experience has a non-zero resource cost, but actually I'm not even hitting 90 yet in a lot of the scenes, so I can't even really honestly tell. Between the adaptive quality 3.0 system and the time warp stabilization, it's really remarkable how smooth the experience is. In fact, it's so good, I should maybe not mention, but I'm going to say it anyway, that my very first test in the headset, before I'd really optimized anything, I had a frame rate that was like 20. Not a good VR frame rate. And yet I was still able to stay in the experience for a few minutes and do what I needed to do, make sure my buttons were working correctly and everything looked the way I expected it to. So obviously I would never put a client in something like that, but for a dev who's working through developing a custom enterprise application, man, it feels good to have something perform that well early on in the development process. A couple other reasons this is exciting. The image quality is so sharp. Looking at the stage from the balcony, that has never looked so good in a VR headset to me. Usually that person on stage from a balcony is just a little clump of pixels. And then when you're up close, the hair strands on the metahuman at a high-res LOD, it's just incredible. Let's take a quick look inside the Unreal Engine project. I started by just taking all the content from the desktop Vive Pro version of the experience and simply making that into a custom plugin. So then all I had to do was grab that entire plugin folder and drop it into the Vive Focus 3, project folder that just comes with the Wave 4.0 SDK. All the project settings looked good. I just had to make sure that all my Android settings were pointing where they need to. That's true for any Android-based project. And then from there, it was just a matter of optimizing the model, dividing the seats up into batches, auto-generating some LODs. My colleague Russell did a fantastic new light bake, and we tested that with the Android OpenGL previewer to make sure it was going to look good on headset. And then we just made a really simple seat jumping system. I made this blueprint for all the people in the seats and then used the events that already exist in the VIVE 4.0 SDK for if a controller enters a collision volume or stays there or hovers there or exits or clicks. It's a small thing, but I can't tell you how nice it is to not have to specify left or right controller. Here, a click is a click no matter what. I added in some custom metahumans I designed in the MetaHuman Creator. They already have their LODs set up, and then I just added a way to manually cycle the LODs, and then also added these panels off to the side that let me test foveation settings, like how much blur and rasterization we get outside that sweet spot in the middle, and then also pixel density, although honestly setting that to auto works great. But it is pretty exciting actually to keep cranking up the sharpness until something bad happens. Both those panels and this frame rate counter over here on top of the MetaHuman were already in the sample level that come with this VIVE 4.0 SDK project. So it was super easy to just drop these blueprints in and use their functionality out of the box. I didn't even touch the Wave VR pawn setup, and then the APK just builds. Builds fine every time. Just make sure to occasionally clear out your intermediate folder. Anyway, with all this being done so far in a couple weeks of spare moments, I'm very excited for the future of where we can go with this. I'll soon be adding in more options of what's happening on stage. I can retarget the MetaHuman head to always be looking at you. I can add in some dash teleportation, some standard locomotion, some snap turning, and even cycling through the stages of the design process. I'll do that with level streaming or maybe the variant manager. Also worth mentioning, AgileLens actually has something of a live theater platform that we're currently developing, primarily targeted for desktop VR, and putting on this headset was the first time that I thought it might actually be possible that we could have a spoke of it that exists entirely on standalone. And even if we can't get everything to render locally, well, NVIDIA Cloud XR and VIVE Business Streaming are looking pretty exciting. So, circling back around, remember how sad I was to tell Brockman that I couldn't get photoreal versions of the design running on standalone? I can't wait to show them this, but then also now, Lincoln Center's Avery Fisher Hall, which is a project that we've been touching since 2012, was renamed David Geffen Hall. The architect was chosen. Things moved along over the years, and now we're at the stage of the design process, just like we were with Brockman, where we're getting a bunch of those questions about, hey, can we a little bit easier? Can we get in a standalone headset instead of always having to go to your office or have some other complicated setup with a laptop and a tethered cable? I mean, do you see what's going on in this picture? This was a perfect example of a situation where we wish we could have just had everyone in their own standalone headsets, but there wasn't enough time to get everything optimized and looking good enough to work in the standalone headset, so we had to have this awkward big old tether to a laptop. I offered to develop the experience more just to give the clients APKs and headsets for themselves, but of course they didn't want to deal with creating social media accounts or to feel weird about their data or to deal with the process of finding an unknown sources menu and doing all this on their own at their home. So yeah, that didn't move any further. But now I can go back to them and say, hey, take a look at this Brockman experience, and I can do something very similar now for David Geffen Hall. I could load them all up with VIVE Focus 3s. We could have some design options to review. We can make it multi-user so we can be in there together. I could be a host and move them around the hall. We could send it all back into Unreal Engine, and then from there back to Revit. We have this whole lovely pipeline set up for that. So the VIVE Focus 3 for us, in so many ways, represents this great big premium reduction in friction, which is what we're all really here for, right? We want to save time, save money, save headaches as much as possible. So as we tinker with this more and more, I'm sure there's going to be tons more features that I discover. And obviously my goal is just to get a big portable VIVE Focus 3 standalone version of my standing ovation thing. I just want that feeling on demand, anytime, anywhere. And thank you. That's the end of the talk. Thank you to Dario and the HTC team for the invite to be an early VIVE Focus 3 developer and to experiment with the Wave SDK 4.0 platform, and of course the chance to be here at ViveCon. This has all been a blast, but if the next ViveCon is real next year or whenever, I want to be flown somewhere on a plane. I don't care where. I just miss travel so much. Please send me somewhere again. To everyone watching, thank you for sticking around. If you want to talk about building AEC visualizations or live event experiences in XR, please do reach out. Twitter's the best place to keep in touch long-term, at iBrews. That's where I post all my crazy experiments and things I'm allowed to talk about. And also, hey, if you want to grab me for any reason during ViveCon, drop by the Agile Lens ViveCon virtual booth, which is a fun sentence to say. Okay, that's enough out of me. Thank you. Goodbye.